Hey guys, today I'm going to be showing you guys how to do this problem. This is 1214 from Hibbler Dynamics 15th edition. It says the sports car travels along a straight road such that V equals 3 square root 100 minus S meters per second, where S is in meters. Determine the time for the car to reach S equals 60 meters. How much time does it take to stop? So what we have here is V equals 3 square root 100 minus S. Okay, and we know that ds over dt is equal to velocity, which is equal to what we have here. So 3 root 100 minus S. So what we're going to do is separate our variables, cross multiply. Write that over 1. We get ds equals 3 root 100 minus s times dt. Now we can divide by 3 root 100 minus s to get dt alone. Or actually, we're gonna leave the 3 on this side. So we're just gonna divide by square root 100 minus s. So ds divided by, and you can move the 3 as well, but I mean it makes it a little more work for you. So I would I would keep it on the other side. So 3dt. So since we isolated, the variables, now we can go ahead and integrate. So integral of ds over root 100 minus s equals the integral of 3 dt. So integral of 3 dt is pretty easy. That's just going to be 3t, and we'll add the plus c over there. That's fine. Um, and for this one, we're gonna have to use u sub. So we're gonna set our u equal to 100 minus s, since that we get the derivative ds, so we can cancel it out. Equals 100 minus s. So du is equal to negative ds. So negative du equals ds. So we're going to plug that into this equation over here. Let's bring it down there. So integral of 1 over, and we said 100 minus s is equal to u. So u times negative du. And let's go ahead and rewrite this right here into u to the negative 1 over 2 u. And let's go ahead and integrate that. So we're going to add 1 to the 1/2, which makes it u to 1 over 2, which is the same thing as root u. Yeah, that's gone. Keep the negative, and we're going to divide by 1 over 2, which means that you keep change flip, which would make this 2 root u, and can't forget that negative 2 root u. Um, so we could go ahead and bring this back up here. So we can say negative 2 root u is equal to 3t plus c. Now, we're going to have to go back to our initial condition here. It doesn't really give us anything stated. So we can just assume kind of that at t equals 0, s is equal to 0. Oh, sorry, I did not plug back in for u, but it's negative 2 root 100 minus s, which is our u over there, equals 3t plus c. Yeah, so at t equals 0, s is equal to 0. So we'll solve for c here. 100 minus 0 is equal to 3 times 0 plus c. And now that essentially means that c is equal to, this turns into 10. So that's negative 2 times 10. So that's negative 20. It was all for c now. So let's get that full equation going there. 2 root 100 minus s equals 3t minus 20. Now we can plug in 4, s equals 60. We get negative 2 uh, equals 60. Negative 2 root 100 minus 60 equals 3t minus 20. Plug that into the calculator. Square root of 100 minus 60 times 2. So we get negative 12.649 equals 3t minus 20. Add the 20 over there. So we get 7.35 equals 3t. We'll divide by 3, divide by 3. So at t equals 2.45 seconds, we'll have the displacement is equal to 60. So that's our first answer right there. Now the second part of the question asks, how much time does it take to stop? So we can go back to our first function here, which is the velocity function. And we know that when it stops, the velocity is going to be equal to 0. So 0 equals 3 root 100 minus s. And we know that if we plug in 100 for s, this equals 0. So 0 equals 3 root 100 minus 100. 0 equals 3 root 0. Yeah, 0 equals 0. So when s equals 100, v equals 0. So that's how far it travels till it stops. So what we can do, go down here, plug in 100 to our equation right here. So let's go ahead and do that. So negative 2 root 100 minus 100, so that goes to 0, is equal to 3 times t minus 20. So that means 20 equals 3t, divide by 3, divide by 3. T is equal to 6.67. And there you go. That's your answers for this problem. Didn't find any solutions online, so went ahead and made this video. Thanks.